Early on when starting with C++, we cover static arrays. Later on, we create dynamic arrays by using pointers. To introduce some of the basic ideas of making a data structure, we are going to start with wrapping a static array and then a dynamic array. Just in case it's been a while since you've done some programming with static arrays, let's look at how they're used. With static arrays, we must have a defined size at compile time. So in other words, you need to declare its size with a integer literal, that is a hard-coded integer, or with a named constant. Additionally, a static array cannot be resized while the program is running, and there's the risk of crashing the program if you go outside of bounds of the array. Elements of the array are stored contiguously in memory, and C++ arrays don't keep track of the amount of elements they have. We have to keep track of that ourselves, or use the sizeOf function. The sizeOf function gives us the size in bytes, so if we know the size of the data type that we are storing, we can do some basic math to get the amount of elements from that. Or we could just make a counter variable to keep track of the amount of elements as we're adding them, just to keep it a little bit more simple and straightforward. Each element of an array is essentially a single variable, but as part of an array we can access each of the element variables by their position in the array. The index is the numeric position in the array. The first index of arrays in C++ is always 0. If an array is of size n, then the valid indexes are 0 through n-1. Let's look at an example of using a static array in a program, and some things we have to look out for. Alright, so starting off with a static array, we use the data type, and we give it a name. Oh, that was the wrong thing. It's string, not static. And we give it a name, so I'm just going to name it games, and then we have to give it the size starting off with. Now, usually if you're hard-coding a number like this is an integer literal, it's just a hard-coded number. It's usually not good to do, so I'm going to create a const int game max and set it to 5, and then use that in there. You can use a named constant to declare the size of your array, but you can't just use a variable. At least not in every compiler. This one apparently is okay with that, but it's not cross-platform. So we're creating a named constant to keep track of the maximum amount of games, and we're setting it to 5 and declaring a static array of strings. So then down here I have just a simple menu that will run and say add game, edit game, quit. We can enter a choice, and then we're going to add our game information. So assuming we're adding a game, we're going to start at item number 0. So I'll also want to have a game count just to keep track of how many games have been added so far. Game count is 0. And so every time we add a game, we add 1 to that. So then we have 1 game, then 2 games, then 3 games, and so on. So when we're going to add a new game, our first position will be at position 0. So we're adding it at where the game count currently is at. So those two correspond. So let's say we're adding a game. We'll want to ask them what the name is. So game name is what? We will use getLine to get a full line of text. This will allow us to get spaces from the user input, whereas just using cin like this will stop at white space. So cin, and we can put in games at position game count to have them enter it. So again, it starts at 0, and we're going to go up by 1 every time we add a new game. So then it will be 1 the next time around, then 2 the next time around. And so let's go ahead and just output added game count. And we can do this for now, and we'll test it out. So I can compile this, compile finished, then I can run it. And it says add game. Say number 1, add a new game. I'm just going to put in some garbage for now. And it added game 0, so at position 0. So now there is no 1 game in there. Add another game, and it added game 1. Add another game. and so on, until we eventually crash the program because we've gone outside the bounds of the array. Alright, so we'll fix that in a moment. Let's also add the edit game functionality, so we'll ask them for what index they want. Int index, and get the index. Then we'll ask them to enter in the new name for the item at that position. So, updated name, get line, cn, and games at that position that was entered by the user. And then we'll just put a message, updated game number index. So again, this compiles, and we can run it. So when we run this, we can go ahead and say edit game, and if I put in some invalid index, it will also crash. So we have no error checking. If we go to add a new game, and game count is already equal to the size of the array, then updating the games array at that position, outside of the array, will cause the program to crash. And with editing the game, when we just ask the user to enter an index, they can enter any number, and it will try to access that. Again, allows it to go outside of the bounds of the array, and will cause it to crash. If we want to add error checking here, we're going to need to keep track of both the maximum size of the array and the amount of items we've added to the array. So, let's add some error checking to this. At the moment, basically, if we go outside of the game count while we're adding a new game, it's going to break. So first, let's check to make sure that the game list is not full. So if game count is equal to, is it called game max? Then we'll just say, well, the list is full. List is full. Can't add more. And not do any operation. Otherwise, if the list is not full, then we can go ahead and run this, and that should be fine. Okay? And then down here, in case 2, actually, I'm surprised that this compiled, because sometimes when you're declaring a variable inside of a case statement, you need to include opening and closing curly braces, and I'm declaring this index here. So in your compiler, if it gives you a hard time, that might be the problem, but we can always talk about that in class as well. So game index, and we'll have them enter an index, and then we'll say, is this index valid? So if the index is less than 0, or if the index is greater than or equal to the game max, then it is an invalid index. Invalid index. And we can either have them re-enter it, or I'm just going to not even do that operation. Basically, it just kind of ignores that they even chose that. So I can run, build, and run. We'll run this again and say, let's edit the game, and we'll edit game 100, and it will say invalid index, and take us back to the menu. Add game, I'll just keep adding games. And then when I try to add it another time, it'll say the list is full, it can't add more. So using just a vanilla static array, we would have to check that the array is not full and validate any user-entered index every time any of these things happens. This means if we're using this array a lot, we're going to have a lot of duplicate code for the same types of error checking. Part of good program design is reducing duplicate code. So how do we cut down on duplicate code and make the array easier to use? We're going to write a class that wraps a static array. As part of a class, we can provide an interface to outside users to take care of the basic functionality, such as insertions, accessing specific elements, and deleting. Because the user doesn't have direct access to the array and has to work with it via the interface, we can use these functions to check for errors before they occur. We're going to make a really simple smart static array for now, and it's just going to contain an array of strings. We will cover templates later in class, which will allow us to create an array that stores any data type. Also, this class will just contain a set and a get function, but it will do error checking for these functions to make sure that the array cannot be misused. To write a static array wrapper, first we need to create a class, and it will contain the array, string m array of size 10. And I will also include a variable, or a named constant actually, to store the size of the array. And then to interface with the array, we'll have two functions, set and get, and we'll add on to this later on. And so this will be how the user can add to the array. By creating functions for this, should be int, we can do our error checking before we do any modifications to the array, and so this makes it a little bit more safe for us. So to define these, we'll have smart static array set, int index, and string value. We'll check to see if the index is invalid, so if the index is less than 0, or if the index is greater than or equal to the max size, then we'll throw an exception. Out of range, invalid index. And to use exceptions, I have my exception library included here. Otherwise, if the index is valid, then we'll just make the update to the array. So if a exception is thrown, it won't get to this line of code, but if the index is valid, it will skip the internal code block here. It won't execute this, and it will come down here. So there's really no reason to use an if-else statement. We can just use a single if and then write the default behavior here. For get, we are going to return a string, which is the value in the array, and we're going to have an index as the input. We can check the index to see if it's valid in that way, and that's fine. And otherwise, if the index is okay, we will return the value from the array at that position. Okay, so this will build, and we can write some basic code to go with this. I'm going to create a smart static array, and we can add some stuff correctly, and there won't be any problem. So set at position 0. At the moment, these aren't going to throw any exceptions anyway, but we should put these in a try-catch block. So we'll go ahead and do that. Try and catch, so we can catch a out of range exception. Out of range. Oops. And we can just output what the error was. So this is not going to cause a problem. We can just run it and nothing really happens. Yeah, because nothing's being displayed. But let's go ahead and try to add something invalid. If we go ahead and add something at an incorrect position and try to build and run this, then it gives us this error message, error, and then it gets the error message from over here, invalid index. That's what we pass to the constructor of the out of range object. Now, if we didn't put this in a try-catch and we had something else invalid, then when we go to build and run, it will complain that the exception was not caught, and then it will abort from the program run. So we'll still kind of get this error message either way. It's better to handle the exception, but if the exception's not handled, it's going to quit the program, and it'll let us know what kind of error occurred. So with the declaration of our smart static array, it stores an array of strings and it keeps track of the maximum size of the array, and it also has a get and a set function. Both of these we must pass in some index to access something. The set function is used to assign values to the array at specific positions. The user has to pass in an index and the value they want, and we can do the error check before updating the array value. If the index is invalid, here we throw an exception. Otherwise, we update the internal array. If we didn't want to use exceptions, our set function could just ignore the command to update the array if the index is invalid. In this example, I'm at least returning true if the update was a success, or false if there is an error, but we're not throwing any exceptions. Sometimes you don't want something to throw an exception because it isn't that big of a deal, and it's good enough to just say, hey, this wasn't updated, so the update was not a success, or false. Our get function also takes an index, and if the index is within a valid range, it will return the value stored in the array at that position. If the index is invalid, again, with this version we're just throwing an exception. Some additional functions that we can add to the smart static array are append, so we could add something to the end of the array, insert something at some index and push everything at that index to the right, so kind of make room for it, remove, where we can remove an item at some index and then push everything after it to the left so that we make sure everything in the array stays contiguous, and we can overload the operators, so we can implement the assignment operator, which is the single equal sign, the equality operator, which is the double equal sign, and the subscript operator, which are the square brackets, and then we could use these operators with our class. We will do this in a programming assignment later. In this lecture, we talked about wrapping a static array within a class, using functions to create an interface, and handle tasks for the structure and do error checking. We will work more with this structure, as well as implement one with a dynamic array, before we get into linked lists, which is another type of linear structure we can use to store data.